Hi, good morning. We are going to be presenting standardization. Our group number is 402 and we have the problem 37. The team members are Regina Vega, Valeria Furber, Luisa Fernandez, and Oscar Sanchez. First of all, what is standardization? Standardization is a process of putting different variables on the same scale. This process allows you to compare scores between different types of variables. To standardize variables, you need the mean, the standard deviation of a variable. The terms we need to know is mu, which is population mean, stigma, which is the population standard deviation, and the x-bar, which is sample mean, n, which is sample size. The formulas we need to know are both of them, and in this case, we're going to be using the second one. How to solve a problem. This is the problem that we have. It's the probability of x-bar being greater than 178. These are the values that we have, which is mu is equal to 175, stigma, which is standard deviation, is 10, and the n is 20. We're going to use the formula, as I said before. We're going to put the values in, and our answer is going to be C is equal to 1.34. We rewrite the probability, so now it's going to be the probability of C is greater than 1.34. In this case, the C is greater than the number, so we have to put 1 minus the probability. To get that number, we search it on the C table chart. Our number is 1.34, and it's a positive. So first we go to the 1.3, and then we look for the second decimal, which is 4. And that's how we get our answer, which is 0.9099. That's how we rewrite our answer, 1 minus 0.90999. And the answer gives us 0.0901, which is 9.01%. Now that we know how to solve it, this is our problem. The population of Metro users after midnight is known to have an average of 28 and a standard deviation of 3.2 years, known to be distributed normally.
In our original question, they are already giving us the average and the standard deviation of Metro users after midnight. So reading my question, that it's number A, the probability of randomly selecting 9 people, which is our n, having an average age younger than 26, which is x, if selection was made at 22 p.m. This is where the question cannot be done. Since 22 p.m. is 10 p.m., which is before midnight, so we cannot use this average and this standard deviation to complete our question.
Okay, so the probability of a randomly selected 9 people having an average age younger than 26 if the selection was made at 1:30 a.m. So what this means is that with the population mean that we had previously is 20 years old and the standard deviation being 3.2 years old, and the sample size that they're giving us in the problem is 9 people. So we want to find what is the probability of these 9 people being younger than 26. So for this problem, we'll be using this formula, since we have a standardization for a specific group of people. So we'll be using the numbers that we were giving previously. So the formula kind of goes like this. So 26 minus 28 over the 3.2 over the square root of 9. So if we plug this in the calculator, we get negative 1.875. Then with this number, we have to go into this chart here, this one. And since, well, we know previously that this chart only contains 2 decimals, and negative 1.8875 is the average of negative 1.87 plus negative 1.88 over 2. So what I did for this problem was basically get these 2 numbers out of the chart, which are 0.0307 from the negative 1.87, and then added it up with the 1 from the 1.88, which is 0.0301, and this all over 2, which gives me 0.0304, which gives us the 3.04% probability that the 9 people that we were giving at the beginning are younger than 26 years old.
So I have the following problem. The population of Metro users after midnight is known to have an average of 28 and a standard deviation of 3.2 years, known to be distributed normally. Find the probability of a randomly selected 4 people having an average age older than 26 yet younger than 28 if selection was made at 3:21 a.m. So since we know the standard deviation and that it is distributed normally, we use the C-test score. So the first thing we have to do is find the P score. So its P is greater than 26 but less than 28. And to pass this to C score, we have to do the following formula. Xi minus X mean is over standard deviation over the population squared. So if we do the following, 26 minus 28 over 3.2 over 4 squared, it's equal to 1.25. So we look for the following value in the chart, and we find that 1.25 is equal to 8994. So we do the same for the 28, and we do C is equal to 28 minus 28 over 3.2 over 4 squared, and we look is equal to 0, and we look for this number in the chart. We see that 0.0000 is equal to 0.5. So we just subtract them. 8.44 minus 0.5 is equal to 0.3944, which is equal to 39.44%.